On Friday, we completed part 1 of the Murder Mystery Lab. In part 1, we tested the DNA of the 3 7th grade science teachers, Mrs. Arbaji, Mrs. Becker, and Mrs. Zuhl, using restriction enzymes. In that part of the lab, you discovered that the hair found at the scene of the crime matched Mrs. Becker's hair, and you thought you had enough evidence to convict her based on the DNA evidence. But now, Mrs. Becker's lawyer is defending her, saying that she was wrongfully accused of the crime. He says there can be no conviction without another piece of evidence supporting your claim against her. He also claims that Mr. Popat and Mrs. Tamburi should also be considered suspects because they also had access to the technology closet. Now, the lawyer hired a team of blood-sniffing dogs to examine the crime scene, and they found several drops of blood in the back of the technology closet. The lawyer is claiming that the blood could be from any of the 3 suspects because all 3 of them have wounds, and it could also be from Mr. Popat and Mrs. Tamburi. The North Caldwell forensics team will need to confirm the blood type of the blood found at the crime scene and match it to the suspects' blood types. They need your help to determine the blood type of the suspects, as well as people who were felt to have frequent access to the technology closet. So whose blood was it?
Hi, it's Mr. Anderson. In this podcast, I'm going to talk about blood types. Blood typing wasn't that big a deal back in the day because when we were cavemen, it didn't really exist, this whole idea of transfusing blood from one person to another. But with modern medicine, it's actually become a really big deal. Now, you should know this. In humans, the ones that I'll talk about in this podcast is going to be the ABO blood typing. And another one I'll talk about is the RH factor. But know that there are about another 30 other families of blood types. And what are we talking about when we're talking about blood types? Well, basically, we're talking about proteins that are found on the surface of our blood cells, or our erythrocytes. And so basically, if we're looking at the ABO system, if you are type A blood, which I happen to be type A blood, that means that you're going to have an A protein, or a specific protein on the surface of your blood. If you are type B blood, then you're going to have a B protein on the surface of your blood. And this is just a comic version. They're going to be really, really tiny. You wouldn't be able to see them. They're just little proteins on the surface, or glycoproteins that are found on the surface of the blood. So if you have AB blood, well, basically that means that you have both types of proteins. And if you're type O, that means that you have none of these specific proteins that are found on your blood. And so
These proteins aren't a function of how healthy you are or how much protein you eat. It's just a marker that's found on some blood cells, and for the purpose of this lab, we're only going to concern ourselves with types A, B, AB, and O blood. Type A, B, AB, and O are only different by what proteins are on their cell membranes. So you see blood type A has proteins on the cell membranes called A proteins, and type B has B proteins, and type AB has both A and AB, and blood type O has neither. And there is a difference in how each blood type is distributed throughout the population because of inheritance patterns. But the reason blood types are important is because of transfusions. If you lose a lot of blood, you might need to receive blood from another person in a process called a transfusion. Up until around 1930, people died from transfusions, sometimes, for reasons no one could figure out. Then, Karl Landsteiner discovered blood groups. He discovered that some blood groups are compatible and some blood groups are not compatible. And then, suddenly, having a transfusion wasn't as dangerous anymore.
because of our immune response. And so if you're type A blood, and so let's remember that that's that purple kind of a protein, that pointy purple protein, well, basically you're going to have that type of blood, but you're going to have antibodies for the other type, the B antibody, we call that. And the reason why is that you have antibodies for every shape possible except the shape that you actually have. And so we're not going to have purple antibodies, but we're going to have these B antibodies, and that's just because we don't have that B protein around. Likewise, if we look at type B blood, it's going to have the B proteins, but it would be silly for us to have those B antibodies because it would just simply attack our own blood. But instead, we're going to have the type A antibodies. If we look at somebody who's type AB blood, well, since they have both of these antigens or both of these proteins on their surface, A and B, then we really wouldn't want to have any other antibodies because, again, they would attack our blood. And then finally, if you're type O, basically if you're type O, since you don't have either of these proteins, then you're going to have antibodies that match up that specific shape. And so again, the antibodies are there simply to protect our body against invasion or against.
I guess it's important to understand what happens if you get the blood that you're supposed to have as opposed to what happens if you get the blood that you're not supposed to have. So let's look at this scenario. What if you're type A, but you're receiving type B? Now, your body will see those B proteins and think that they're a stranger. And of course, your body's going to protect itself against that stranger by clumping up all of the invading strangers. This kind of clumping is called agglutination. And what does agglutination feel like? Well, you die. It could be very, very dangerous. Most people die from that, and that's why most people died before 1930 when they received transfusions of the wrong type of blood. But on the other hand, what happens if you're type AB blood? Now, you have A's and you have B's on your blood. What happens if you receive type B blood? When an AB person sees B blood, everything looks normal to them. Everything on the B blood is something that they're familiar with. So they don't react badly. They think it's a friend. No clumping, no dying, and everything's wonderful. So as it turns out, if you're blood type A, you can receive blood from A because you're familiar with A, and you can receive blood that's type O because there's no proteins on O that you recognize as foreign. If you're type B, you can receive type B blood because it's familiar to you, and you can receive type O blood because there's nothing on O blood that's unfamiliar. And if you're type AB blood, you can receive A's because you're familiar with A's. You can receive B's because you're familiar with B's. You can receive AB blood because you're familiar with A's and B's. And you can receive O because there's nothing on O that's foreign to you. If you're blood type O, you can only receive blood from other O's because a person who's blood type O is going to see A's and B's as foreign. Now, looking at this chart, maybe you can guess which of the blood types is the, quote, universal recipient, because it's the blood type that can receive all of the other blood types. Which one do you think that is? If you guessed AB, then you're right, because AB can receive A, B, AB, and O. Maybe you can guess which blood type is the universal donor, because they can donate to everyone. Which blood type can everybody receive from? If you guessed O, then you're right, because A can receive O, B can receive O, AB can receive O, and of course, O can receive O. So how does this relate to our murder mystery? This is the procedure that a scientist or a doctor will use to determine your blood type. They put what's called anti-A into one well of a plate, one little dip in a plate, and they put anti-B into a different well. Now, anti-A is going to clump up any A proteins, and anti-B is going to clump up any B proteins. So then what they do is they take the mystery blood and they put some in the first well and some in the second well, and they stir it. Of course, we're going to use a separate toothpick to stir them so you don't get any kind of cross-contamination. And of course, we're going to throw it away. We're not going to reuse toothpicks. And then we're going to look for agglutination. If blood clumps together, we call it agglutination, and it looks kind of like this picture on the left. See how it kind of looks like jello? That means that the anti-A clumped up whatever A's were in there. Now in the B well, we put anti-B and we put the blood, and there's no agglutination, which means that the anti-B, which would have clumped up any B's if they had been there, it didn't find any B's. So there's no agglutination because there's no B's in this lab, in this blood type. And that means that this sample is blood type A. It has A proteins, they got clumped up. It doesn't have B proteins because it didn't get clumped up here. try this one. What type is this? There's no clumping in A. There's no clumping in B. So are there A proteins? No. If there were A proteins, you'd have clumping over here. Are there B proteins? No. Because if there were B proteins, you'd have clumping over here. So when there's no A's and when there's no B's, what blood type is this? If you guess O, then you're right. Let's try another one. This sample is clumped in the A well, but not in the B well. So if it clumps over here, then there's A proteins in the blood. And if it clumps over here, there'd be B proteins in the blood. But since it didn't clump over here, that means there are no B's. So what kind of blood has A proteins but no B proteins? If you guessed blood type A, then you're right. Blood type A has A proteins. They're the ones clumped up over here. And it does not have B proteins. They're the ones that didn't clump up over here. This picture shows blood that clumped in anti-B, but not in anti-A. What type of blood is this? Since there's no clumping or agglutination here, it doesn't have any A's. And since there is agglutination here, it does have B's. What type of blood has B proteins but no A proteins? This must be blood type B. What type blood do you think this is? If you guessed AB, then you're right. It's agglutinated in the A well because it has A proteins. And it's agglutinated in the B well because it has B proteins. And blood type AB has A proteins and B proteins.
So this is your lab setup. You have this tray. Now see how there's an A on this well and a B on that well. This is where you're going to put the anti-A, and this is where you're going to put the anti-B serum. This well says RH, and that refers to the positive and the negative that sometimes you hear about your blood. Like you might hear someone say they are A positive, or that they're B positive or O negative or whatever. We're not going to test the RH, so you leave that well blank. You also should have some of this. This is anti-A serum. You should have some of the yellow stuff, which is anti-B serum. You should have the blood of the person that corresponds to the paper that you have on your desk. And you should have 2 toothpicks. Okay, you're done. You're not going to reuse the toothpicks. These are garbage after you're done. So here's what you do. You take your anti-A serum, everybody, and you put 2 drops into the A well. If you put 3 drops or 1 drop, it's not the end of the world. Make sure you close it up tight. Then you take your anti-B serum, the yellow stuff, and put 2 drops in the B well. Now, I did 3. It's very important when you do this that you don't touch the tip into the well, because then you could be contaminating it. So just make sure it just drops in like that. Doesn't touch. And then you put a little bit of blood into each one. 1 or 2 drops should do it. Make sure you're not touching the eyedropper into the liquid. Make sure it's actually dropping. See that? All right, now you take your toothpicks and you stir, but you use a different toothpick for each well. So I'm going to use this one over here, and I stir a little bit, and then I'm going to put the toothpick down, and I'm not going to pick it up again. I use a different toothpick to stir this well. See that? And then you look to see your results. Do you see any clumping or any signs of agglutination in either well? Now, every table is going to be doing a different person's blood. And then, after you have the results from your table, you're going to walk around to the other tables, look at their blood, and see if you see any signs of agglutination. Now, in this case, do you see how in here, the liquid is all thin, no little black dots, no dots or anything. But in this one, you see this one looks different. This one has some little dots in it. It's a little bit thicker. It looks almost like it's turned to jelly a little bit. And you can kind of tell by looking at it, I don't know if this is a good video to see it, that there's little black dots in it. Sometimes if you pick it up, you might be able to see it from the bottom. See how there's like little clumpy things in there? and not in this one. Can you tell that there's little clumpy things in there, but not in there? That means that this blood agglutinated in the A well, and it did not agglutinate in the B well. So then you go to your data table, and I was using Mrs. Zuhl's blood here, so next to Mrs. Zuhl's blood where it says anti-A present, yes, it clumped in A. Anti-B present, no, it did not clump in B. So the blood type, when you have it, when it clumps in A but not in B, the blood type is A. And then you go around the room and you fill in all of this for all of the other people that you tested. Why don't you pause the video now and then turn it back on after you're done collecting all your data. All right, now that you've got all the data from everyone in your group and everyone in your class, now you need to clean up. You need to make your tray look the way it did when you got there. Those toothpicks are garbage. Please throw them away. We don't want any contamination. Then after you throw them away, get 2 clean ones and put them on your tray. Your well plate has to be rinsed with water and then dried with paper towels and then put back on your tray. Please pause the video now. Come back when you're done.
This image sums up what we just learned. Blood type A, you'll get agglutination in the A well. Blood type B, you get agglutination in the B well. Blood type O, you don't get any agglutination. And blood type AB, you get agglutination in A and B. All right, so back to our murder mystery. Blood samples were taken from all of the suspects. These are the results. Pay close attention to the wells that agglutinated and record what blood type you think each suspect is in your data table. Mrs. Becker has agglutination in A and B. Mrs. Zuhl has agglutination in A but not B. Mrs. Arbaji has agglutination in A but not B. Ms. Sweeney doesn't have any agglutination. Mr. Popat only has agglutination in B. And Mrs. Tamburi also has no agglutination. Record what you see in the data table and what blood types you think each of these people are. To summarize, Mrs. Becker must be blood type AB. Mrs. Zuhl must be blood type A. Mrs. Arbaji must also be blood type A. Ms. Sweeney is blood type O. Mr. Popat is blood type B. And Mrs. Tamburi is blood type O. As it turns out, we also took blood at the crime scene, and this is the results. So now, based on what you see here, determine what type of blood was found at the crime scene, and decide if the case against Mrs. Becker is stronger now, or is it weaker? Are you more sure that she did it, or are you less sure that she did it? If you found this type of blood at the crime scene, what do you think?